Okay, we are going to continue data and signals, the physical layer. Okay, so up to now we have discussed analog signals. Now we are going to discuss digital signals. Okay, so in addition to be to being represented by analog signal, the information can be represented by a digital signal. For example, a 1 can be encoded as positive voltage and 0 is 0 voltage. So a digital signal, it can have more than 2 levels. Okay, but these are discrete levels. In this case, we can send more than 1 bit for each levels. So in general, if a signal has L levels, then each level is representing then if a signal has L levels, then each level needs L log 2 L bits. Okay, so we can see that the in addition, so the analog signal, the information can be also represented by a digital signal. So the digital signal, if the information is represented, then each level of the signal, okay, each level of a signal, if a signal has L levels, then each level will needs L logical L2 by L bits. Okay, so let me discuss it. For example, here you can see that this signal, it has 2 levels, higher 0, level 1, this is level 1, this is level 2. Okay, so level 1 is level 2 is representing 1 1 1 1, and level 0, level 1, it is representing 0 bit. So level 1, it is representing 0 bit. So here it is level 1, so it means that it is 0 bit, it is 0 bit, it is 0 bit. Okay, so this is the digital signal, okay, with respect to time. Similarly, here this signal, it has 4 levels, level 4, level 3, okay, level 2 and level 1. This is level 1. So you can see that this level, suppose level 4, it is representing double 1. So here it is level 4, it is representing double 1. Suppose level 3, it is representing 1 0. It is representing 1 0 bit, 2 bits 1 0. And here level 4 is representing 2 bits double 1. So level 2, it represents 2 bits 0 1. So it is representing 0 1 bits. So here it is also, the signal is at the level 2, so it is representing 0 1. Here this is level 1, so it is representing 0 0 bits. Okay, so here the signal is at the level 1, so it is representing 0 0 bits. Okay, so each level, it is representing 2 bits in the, when a signal has 4 levels. Okay, but when a signal has 2 levels, then one level is representing 1 signal. Okay, so similarly, for example, so if a digital signal, it has 8 levels, then how many bits are needed per level? So you can use the formula L log 2L. So L is how much? 8. So log 2 8, it will becomes 3. So it means that each level is representing 3 bits. Each single level is represented by 3 bits. Okay, so what is bit rate? Okay, so most digital signals are non-periodic. They are not repeating their periods or same interval time. This is called non-periodic, and thus period and frequency are not appropriate characteristic. So we use another term which is called bit rate. So bit rate is used to describe the digital signal. So the bit rate is the number of bits sent in 1 second. In 1 second. So how many bits are sent in 1 second? This is called bit rate, or this is called bits per second. It is represented BPS, and it shows the bandwidth. It shows the bandwidth. Okay, so how many bits are sent in 1 second? This is called the bit rate. Okay, so the bit length is the distance of 1 bit that occupy on the transmission medium. For example, suppose there is a, for example, this is an example, which is, suppose a user needs to download a text document at the rate of 100 pages per second. Okay, so what is the bit rate required? How many bits can be retrieved per second? So you can see that, suppose if a page has 24 lines, Okay, 24, and each line is of 80 characters, and one character is 8 bits. So 8, so 100 into 24 into 80 into 8. So this will be the bit rate required. Okay. So similarly, a digitized voice is, it has channel, for example. This will requires this much bandwidth. Okay, bit rate. Okay. So another important characteristic that, for example, how can we send a digital signal from point A to point B? How a digital signal is transmitted from point A to point B? So for their purpose, we have two types of approaches. One is called baseband transmission. Baseband transmission means sending a digital signal over a channel or a link without changing the digital signal to analog signal. This is called baseband transmission. Baseband transmission means, so how the digital signal is moved from one point to another point. So one is called baseband. Baseband means that the sending a digital signal over a channel without changing the digital signal to analog. That is mean the digital signal is generated by a node, and that digital signal is transmitted over the link. This is called baseband transmission. Okay. So this is, for example, this is the node. It generated a digital signal. So the same digital signal is transmitted, okay, without changing into analog signal. So this is called baseband. Okay. So the bandwidth of here, for example, you can see this is a low pass channel, wide bandwidth. Low pass channel is the one whose frequency start from 0. So it has wide bandwidth. Here it is a narrow bandwidth. The bandwidth is lower, is less as compared to the bandwidth here. Okay. So the baseband transmission, its importance is, a baseband transmission of a digital signal that preserves the shape of digital signal is possible only if we have low pass channel with an infinite or very wide bandwidth. Okay. So an example, for example, is an example of dedicated channel where the entire bandwidth of the medium is used as one signal channel is a LAN, local area network. Okay. So we use in this. So almost every wired LAN today use a dedicated channel for two station communication with each other. So in a bus topology that we have discussed in chapter number 6, LAN with multiple point connection, only two stations can communicate with each other. If more than two communicate with each other, then it causes packet collision. So the other station needs to refrain from sending data. In a star topology, the entire channel between each station and the hub is used for communication between these two entities. So these are the examples where the baseband channel is used. Okay. So if the available channel is a band pass channel, we cannot send the digital signal directly. For this purpose, what we do, we need to convert the digital signal into analog signal before transmission. So this is called broadband channel. Okay. So we can see that this is also called modulation. This is also called modulation of digital signal. So here we need a converter that converts digital signal into analog, and similarly when at the receiving end the analog signal is converted back to digital signal. This is called modulation. Okay, and this is called broadband channel. Okay, so we have discussed that there are two types. One is called baseband and one is called broadband. Okay, so this is the broadband. Okay, so an example of broadband transmission using modulation is the example of computer data. Okay, is the example of, so one example of broadband communication. For baseband we discuss data used in LAN. Okay, but the broadband transmission is using the modulation is the sending of computer data through a telephone subscriber. Okay, the line connecting a resident from the central to the central telephone office. These lines are designed to carry voice with a limited bandwidth, and voice is continuous signal. So the channel is considered as a band pass channel. So here the digital signal cannot be sent. So what we have to do, we have to change the digital signal into analog before transmission. okay, and at the sending side, okay. So we convert the digital signal from the computer to an analog signal and then send the analog signal. So we can install two converters, okay, to change the digital signal to analog, and at the sending side and at the receiving we need a converter that change from analog signal to digital signal, and vice versa at the receiving end. So the converter in this case is called modem, which we discuss in chapter number 5, okay. So we will not discuss this modem, okay. So up to now we have discussed the digital signal and how it is converted. So we discussed the bit rate, we discussed the channel, and we discussed the digital signal, okay. We discussed the digital signal, and we also discussed the bit rate, and we also discussed the how the digital signal can be transmitted. So one is called baseband transmission and one is called broadband transmission, okay.